All right, welcome to April's technical meeting. The main topic for today is talking about calibrating equipment, specifically checking your hoses for leaks and field calibrating your blower door and your duct blaster stuff. Before we get into that, we'll go through just our training opportunities, our production, and then we'll jump into the main topics for the day. So as far as training opportunities go, we've got a couple of things coming up at the training center. We've talked about these multiple times, but just want to give you one last reminder on one of them anyway. So this month on April 22nd through the 24th, we are doing, this is called the Neat Meal 101. And this is where I spend 3 days with you and you learn how to run the energy audit. So this is a class, if you need to learn how to run the energy audit, it's a class for you. Right now I think we have 6 or 7 or 8 people registered for it, so that's the perfect class size. I am going to close the registration at the end of this week because I have to turn in some paperwork to get food and stuff for the meeting. So you have until Friday. If I don't have if I don't get an email from you by Friday, then you will not be able to join us in the class. So reminder on that, just send me an email. Your email has to let me know that you have your coordinator's permission and you want to attend. And then everybody that is attending, you've got to send me one audit before you come to class. I want you to muddle your way through an audit before you come to class. You'll get a lot more out of the class if you've at least gone through it once. Any questions on that class? I'm hearing none. Next one is we are doing a BPI Energy Auditor class in May. When we put it out, we had 2 different dates because we weren't sure when Dalton was going to be available. Now that he's nailed down what he's doing, we know that we are going to hold that class May 13th through the 16th. There are only 4 seats in the class, so it is the first 4 people that get me their BPI letters get a seat. I have 1 letter so far. I know a couple people have turned in their applications to BPI and they're waiting to hear back. But if you need your auditor certification this spring, you better hurry and get me your BPI letter. Also remember, those who, just because you've sent us a letter does not mean that you're ready for the class. You must also complete all of the state prerequisites before you attend the class. If you have questions about what they are, if you're using that auditor in training form, that lists all the state prerequisites. It's everything on the LMS. But anyway, if you'll just check on your auditor in training form and make sure you have everything done on that, then you'll be ready to attend that class. Any questions on that one?
Hey, Matt, I have a question on the other one before that.
Yeah.
When will you be doing the next one of those?
The next one of those, probably not until next spring. If I'm not mistaken, the last time I looked at, that's a class if you're a QCI and you need to learn how to take the audit or run the audit. I think most of the people that are currently QCIs, your QCIs, most of them don't expire until next fall.
Right.
But if you wait until next spring to take that class, and really if you're waiting until next spring to start doing your 10 energy audits, you will be tight on time. You'd be wise to get going on that this year if you can. I think you could still do it if you start next spring and move forward from there, but it's going to impact your agency because you're going to have to interject yourself on some of the audits. And so, yeah, take some time and plan accordingly. It does.
Well, we were going to come to this one, but we couldn't make the days work, so we're just wondering when the next one's going to be. So.
Gotcha. And if, go ahead.
I was just going to ask you, when are you going to do a recertification? this year? Because mine's up in September, I think.
For QCI or EA?
Auditor, for the BPI auditor.
Yeah,
Yeah,
you can come to the May 13th through the 16th class, I believe, Tony. I think we'll have room for you in there.
Now, the May 13th through the 16th, that's going to be the full class where everybody sits and then takes.
Oh yeah, that's right.
Tony, if you're just wanting to come and take the test, we can actually kind of just schedule that with you.
Okay.
Yeah, Tony, just get with me, Tony, and we'll make sure you get it. I've got a list, so you're on my radar. We'll make sure you get recertified before you expire. And I think you've been through it. All you need to do is come up and take the test. I don't know that you need to spend a bunch of time in class.
Right. I haven't done the QCI stuff. I don't know if I need to do that or is it just part of the new test?
If you want the QCI, then you can, once you get done with your energy auditor class, you can take the QCI test is now just a 50-question test.
Oh, okay.
If you want to try to take it, it's fine with me as long as it's fine with Ian. I don't care.
Okay.
But it's the process in that is you first have to have your energy auditor, and then you can do the QCI thing. So you can take that test, or in the future, as we schedule the QCI training, you could come and take the QCI training and then take your test. But you can do that stuff separate from the energy auditor certification stuff.
Correct. And I'm not sure what the new QCI training will look like just yet. Everything is in flux right now because they changed all the JTAs, so we're working on it, but we'll keep you posted as we figure it out.
Cool. And then the last thing I had for training opportunities, Wade sent out an email to, I think, most of the people in this group, just giving them a heads up about an RMGA Education Summit, which is next week. It looks like it's going to be some really good training on updating on residential codes, and it also offers 6 of the Doppel CEUs. So if you are the qualifier for your agency, everybody who's a qualifier for B100, R100, S350, I think all of those expire in November of this year. So
Correct.
Make sure that you have your 6 CEUs in place so that you can get, so that when you re-up your license in November, that you'll have everything you need in place. So this is a great opportunity for that. I think this one is it like $150 or something? Wait.
It's $115 a person if you're an RMGA member. If you're not an RMGA member, they'll probably ding you for another $50 or something like that.
Yeah.
I sent the email mostly to coordinators and those who I know have licenses. So if you're in this group and you're unaware of it, get with your coordinator or send me an email and I'll send you over the registration forms and all the information you need to get signed up for the class. But as Turner said, this is a stellar opportunity to just get your 6 CEUs done in one class.
Yeah.
Hey, Wade, does that cover the 3 HVAC-specific credits that you need?
Yes, it does. It covers core. You need 3 core, which is the business law and all that, and then you need 3 professional. So it covers your 3 core and your 3 professional.
Cool. Anybody aware of any other training opportunities that this group ought to know about? If you are, just, again, you can just send them our way. We can kind of act as a clearinghouse. Any one of us really at the state, Wade or myself are great ones to run that through. And we'll kind of try and share them with the rest of the group as we see fit. So under the new business section, just a reminder, we will have our next technical meeting on May 7th. That'll be the first Tuesday in May. There was this 30-year measure life. What this is the, what's the group that worked on this, Wade?
Energy Out West.
Energy Out West put in a lot of effort to basically get DOE to allow weatherization programs to lengthen the life of some of the measures in the audit. Right now, the longest measure life in the audit is 25 years, and I think most of it was limited. Yeah, I think some of the insulation measures were 25 years, and then like HVAC stuff is about 13 or 15 years. Anyway, the Energy Out West group did enough work and showed DOE that these measures do actually have a longer effective life. And so DOE approved a process where we can actually lengthen the life of some of these measures. We submitted the paperwork to DOE to lengthen the life of some of these measures, and DOE approved our request. So what that means is that starting July 1, every agency will be lengthening the life of some of their insulation measures and some of their HVAC measures. All you really need to know at this point is that it's coming, and I will schedule a meeting either toward the end of May or in June where I will need someone from every agency to, we'll probably just do an online meeting and we'll go through the process, what you have to do to set up your setup library so that all of your measures are the proper length, or they're set to the 30-year mark instead of the 25-year mark. So, but it's kind of a weird process because they had to kind of put it's a Band-Aid basically because of the way the NEAT is set up. So, anybody have any questions or concerns about that? All right, I'll be sending an email to coordinators, and they'll pick somebody from each agency to attend that meeting and get that set up properly. So, the last thing I have is our production update. I just want to show you guys production numbers. So, these are the same charts I've been showing every month. This first one is the production as of the end of March. So, on the left-hand side, the light green is kind of the, let's see, that's based on every agency's goal. That's where we should be on production, and then the dark green is where we actually are on production. So in March, if we had met every agency's goal that they'd set for themselves, we should have had 49 units, and we were able to turn in 32 units. Over on the right-hand side, this is kind of a running total. If we had met our goal every single month, we would be at 398, and right now we're at 281 for the year. And then for crisis stuff, on the left, the light blue, that's basically a 4-year average. That's what we've done on average in the last 4 years. And then the dark blue is what we turned in last month. So normally in March, we only have about 37 crisis jobs, but we turned in 68. So not really sure what's going on. It kind of looks like this spike that we normally have here turned into a spike here and here, but I also think we're getting better at reporting all of the different crisis jobs. We're getting multiple crisis BWRs for the same client. So I think that's why we're getting different spikes. But we want to let you know we are aware of all the crisis work you're doing, and we appreciate it. We're aware of how that impacts your weatherization production as well. Over here on the right, this is the same exact things going on. The light purple is a 4-year average, but this is a 4-year average of the clients that you've served, and in an unduplicated count. And then the dark purple in the front is basically showing that if we only count every client one time, it just shows you how many clients you served. On average, we've been serving, like February was 60, March was 64, and in February we had 53, in March we had 32. So it looks like we are serving fewer clients. We are doing more crisis jobs. So, you know, I think there's some connection there that's kind of important to note, that, you know, our processes are breaking this apart into more crisis jobs, but the number of clients we're serving hasn't really gone up. I think I saw a comment from Ian mentioning that we did have a colder, let me see if I can see the comment. It was colder in February and March this year, so that could also represent that. Probably does. I think you guys are much better in touch with what's going on with the crisis than we are, so that's probably a good representation of what's going on there. So thanks for that comment. Anybody have any questions or concerns on our production numbers? And sorry, if you can see any of my notes in the bottom, those are from last month. I forgot to update those, so I did not check to see which agencies actually met their individual goals for the month. I apologize. I normally do that. But I will check on that and give credit where credit is due next month. So, all right. That's all the new business I had. Before we jump into these main topics, does anybody have anything else that, any questions or anything that we need to address? Okay. For the main topic of the meeting, Dalton and I actually worked to make some videos, and all of these videos are on the Utah Weatherization YouTube channel. So after this meeting, if you need to go back and find any one of these videos, we have published them there so that you can hopefully find them quickly. We've published them as individual videos so that they're a short video that you can reference whenever you need them in the field. I do need, once I start this video, I need you guys to just let me know that you can actually hear it, because it's kind of a weird configuration to get audio from a YouTube video into a webinar. But anyway, the first video we actually recorded, but we had some technical difficulties. So on this first video for checking your hoses for leaks, we're actually going to watch a quick video from Corbett Lunsford where he shows what it looks like when you have a leaky hose and when you don't have a leaky hose. And then after that, you'll see the following 4 videos are videos that with Dalton explaining stuff in it. So let me go ahead and hit play on this one.
All right, so we're going to show you guys how to test the hoses to make sure they don't have leaks. You want to set your gauge up. You want to have it on pressure, and we're going to put the hose from input on channel A to input on channel B, and the pressure should hold. It should not continuously drop, and it should be equal across both the channel A and channel B. So I'll go ahead and hook this up. So I'm on input on channel A, input on channel B, and now it should kind of steady out and hold the pressure. And so we're at 109, 107, 106. So we'll let it go for just a few minutes, but it looks like this hose is bad because it's continuously dropping pressure. Yeah, so it's kind of like a balloon just slowly deflating. So we know there's, I've got good connections on the end here. I know it's not there, but somewhere in this hose, it's got a hole in it. What you want to do once you identify that the hose does have a hole in it, you'll want to try to identify where that's at, because sometimes, you know, if it's not in the center of the hose and there's enough usable hose left, you can just trim off what's bad and keep the good part. On this hose, I've actually looked up and down it, and I've ran my fingers up and down, and I can't fill a hole. I can't identify where the hole is on this hose. So I'm just going to throw it away. This one's no good. If I can't identify where the leak is at, it's compromised. So, all right, so we're going to put another hose on here to kind of show what it's like when you've got a good hose. I've got the ends trimmed up so they're not expanded out and going to leak at that. And I'm just going from the input on channel A again to the input on channel B. Okay, so it's actually climbing in pressure, which is a good thing, and we got the same pressure on each side. It's not dropping in pressure. It's kind of steadily just holding where it's at. It's moving together. It's not being all erratical. So yeah, this would be a good hose, and you can see the difference between this one where it started to just continuously drop, and this one's kind of holding pretty good. So.
Make sure you do it. We were surprised to find out how many hoses had holes in them at the training center.
Yeah. And sometimes feeling along them does not find the hole. So if you can't find the hole, throw the hose in the garbage and buy a new one. All right. Next video is field calibration of a DG1000 and DG1000.
So we were going to show you guys today how to field calibrate your gauges. You need to start off by having one gauge that has been calibrated at the factory. This DG1000 that we're going to use as our standard gauge was calibrated March 4th, 2019. So we're going to use that as a standard gauge. And then we've got this gauge that's out of calibration. It was last done in 2016. We're going to see if it's still within its specifications. We've got 30 feet of hose. We got some tubing that we can connect to both the gauges, and we also have a syringe. It's kind of the equipment that we need to have, and we've got a form to document our readings on. So I'm going to just connect our hoses, and for our standard gauge, we want to be on channel A, the reference port. On the gauge that we're field calibrating or testing, we want to be on reference A and reference B. And these hoses all connect into the single 30-foot hose that's going to be run into the syringe. Once you get those gauges hooked up, you want to have the syringe pushed in all the way. And when you hook it up to the hose, and it should show a little bit of a negative pressure on the channel A of your standard gauge. And so now we want to check, there's 4 different points of pressure we want to check our gauge at: a positive 500 pascals of pressure, a positive 50 pascals of pressure, a negative 50 pascals of pressure, and a negative 500 pascals of pressure. And those are the 4 points that you check to determine if your gauge is within calibration. And so the first check, this positive 500 pascals of pressure, we should be within 5 pascals of the reading on channel A of our standard gauge and the readings on channel A and B of the gauge that we're field calibrating. So let me go ahead and put this under pressure, and then once I get it up to 500 pascals of pressure, and that's with, and you can have plus or minus 30 pascals when you're doing this. But once we get up to that pressure, I'm going to set my time average from 1 second to 10 seconds on our gauges and get them zeroing out in sync with each other. And also you want to note, like with the syringe and stuff on here, you will have a little bit of leakage, so your numbers are going to start to drop a little bit. So you just kind of got to take your readings when the gauge zero out at the same time. So I'm going to first change this one to 10 seconds, and it kind of counts on the gauge for me right there. So when it gets ready to, or when it gets close to 10 seconds, I'll click the time average on this one. Okay, so they should be zeroing out roughly around the same time. We're at 500 pascals of pressure. We got 487, 738, 486. Okay, so we were only 1 pascal difference between channel A on our standard gauge and channel B on this gauge, but we're way off on channel A. We're way more than the 5 pascals allowed. So right now, I mean, just off of that test, it fails, but we'll check at our other pressures too. So I'm going to pull out the syringe, let the pressure out of the hose. I'm going to leave this gauge on the 10-second time average, or actually I'll change them both back to 1 second. It's easier to have it on the 1 second time average to get to the pressure that you need to have it at, and then once you're at the pressure, you can change the time average so it'll hold the pressure reading long enough for you to write it down. So our next pressure that we want to check is a positive 50 pascals, and we should be within 0.5 pascals of pressure to our standard gauge. Our calibration gauge, or the gauge that we're calibrating, should be within 0.5 pascals of pressure. All right, so I'm going to connect the syringe now to the hose, and again, I got it all the way up to the front. We've got a negative pressure on our gauge, so we're looking for a positive 50 pascals plus or minus 5 pascals. So it's not going to take very much to get up to Okay, so now I'm going to set the time average again. I'm going to go for 10 seconds, just so it'll hold a reading long enough to read all 3 pressures at the same time. Okay, and I'll give it a sec just to go through one more 10-second cycle. All right, so we're at 50 pascals here, 50.9, 76.5, and 50.9 over here. So again, this gauge is way off on channel A of this gauge. I wouldn't even go farther as to test the other 2 pressures. Between testing at the 500 pascals and the 50, we can tell this gauge needs to go back to the factory to be recalibrated. So I would just end the test on this one right there. Now I've got a DG1000. I'm still using that standard 1000 that was. calibrate at the factory just earlier this month. We've got one that's just barely on March 7th. It expired its 2-year calibration, factory calibration. So we're going to do a field calibration on it. And again, we want to hook up the same way as before. Reference on channel A, reference on channel A and B on the gauge that we're field calibrating. Okay, and again, I've got it on a 1-second time average for right now until I get up to the 500 pascals of pressure, and then I'll change it to the 10-second time average. So. All right, so now we got it up to 527. I'm going to drop my time average on both of these and click 10 seconds at the same time. That should kind of align the time that they're zeroing out. So this one, I didn't have it on pressure. So I've got to go in here, click on pressure. Now we're on pressure. Okay, I'm going to let them both click here another time. Okay, so I have 490, 493, 492. So they're all within 3 pascals of pressure on that test. So it passes that. Okay, so I'm going to go ahead and document that on our form so we can keep track of what they were. So we had a 3 pascals of difference on channel A and a 2 pascals difference on channel B. There's that form. You got the serial number, the date, the technician, and then the pressure readings that we're getting, and we're within 5 pascals of pressure. So it passes there, but now we're going to check our 50 pascal measurement that they want us to take. I'm going to change this back to just this, our standard gauge. I'm just going to change it back to a 1-second time average so I can have a more accurate reading of where I'm at on pressure. So again, got the syringe pushed in all the way. And don't take too much to get up to 50. And again, it's 50 plus or minus 5 pascals, so between 55 and 45. All right, I kind of hit the time average again at the same time on those, so they should be in sync. So we got 49.6, 49.7, and 49.7. So there's only a 0.1 difference from the standard gauge to channel A and channel B, and we're allowed a 0.5. Let me put this over here. We're allowed a 0.5 difference, and so the gauge passes that test. Okay, now we're going to be doing a negative pressure check on it. So instead of having the syringe pushed in, you want to have the syringe out. Because before we were creating a vacuum on it. Now we're going to go back up to negative 500 pascals. Plus or minus 30. So I kind of like to go to the top range of that just because as it starts to drop, gives me time to work with it. So again, I'm going to go put us on a 10-second time average. All right, we're 504.3, 505, and 505. Okay, so we're only 1 pascal difference on both channel A and B from our standard gauge. And we're allowed a 5 pascal difference. So it passes that one. I'm going to change this back to a 1-second time average so I can see a real time of where my gauge is at. We're looking for negative 50 plus or minus 5 pascals. And the slightest movement on this thing will make a drastic difference. So I'm going to go back to a 10-second time average. And this one, again, we're looking for, it needs to be within 0.5 pascals of pressure. So we got 52.8, 53, and 53. So we've got a 0.2 pascal difference between our standard gauge and channel A and channel B. And so we're within that 0.5 pascals of difference. All right, so now that I've calibrated this gauge and verified that it is within calibration of the factory, you want to make some kind of a label that just shows that it was field calibrated and the date that it was field calibrated. And you want to, because that's going to determine, like a factory calibration is good for 24 months, where a field calibration is only good for 6 months. So you need to remember that when you do field calibrate, you've got to do it more often. So that could look something like that. And then I've got the backup documentation to show who did it and that gauge actually was field calibrated.
All right, questions, comments on that one? Anybody ever done that? Field calibration?
Yes. Dalton showed me how.
So Ian made a comment that you can use the TechLog software, the TechLog software to actually log the pressures. Has anybody been able to hook the TechLog up to their DG1000?
Yes, I have.
You have? Okay. We spent way too much time trying to get ours to connect, and we couldn't make it work. Maybe we need to run a software update or something, but basically the documentation from the Energy Conservatory says that they highly recommend that you use the TechLog to do this procedure, but we weren't sure if it only worked on the DG700s, because that's when they wrote the documentation, or if it actually works on the 1000. So it's good to hear somebody's been able to hook up the 1000.
Yeah, we could not get the gauge to actually hook up with tech log.
Yeah, it wouldn't identify the gauge. It's weird with multiple gauges.
With either of our 1000s.
Yeah.
So,
Mine hooks right up. I think maybe you need to look at a software update on your gauge or something.
We might need to. There was one other thing in the video. Dalton said 6 months.
yeah. On the field calibration, I said 6 months in the video. It's actually annually if you field calibrate. So you go 1 year, 12 months.
So the calibration is worth 12 months. Just make
Yeah.
sure you've got it documented and on file at your agency, and we'll fix that on the video and update that.
Were you trying to hook your gauges up via your iPads?
No.
Oh, okay. I was going to say I've hooked mine to my laptop, but not to my iPad.
Yeah.
Yeah, we tried on our laptops. We couldn't get it to go for some reason.
All right. The next video is shows how to do a blower door field calibration, and the one after that is a duct blaster fan calibration. These two processes are identical, so we're only going to watch the blower door one, but as you're thinking about it, just bear in mind the duct blaster looks the same. We made 2 videos for it, so if you need the video in the future, you can grab it, but we'll just go ahead and watch the blower door one for now.
All right, so we're going to go over the procedure of field checking the Model 3 blower door. We're going to start by doing a leakage and damage test on the flow sensor, and that's this white cap here on the end of the motor. And basically what we're checking on it is we want to make sure that there's no damage to it or the hose that runs up to the flow port on top of the blower door, and then also we're looking for like any kind of cracks and stuff in the actual housing. So first, you just want to kind of do a visual. I want to make sure it's mounted correctly, that that these 3 metal clips are holding it nice and snug on the motor. I'm just looking at the housing, making sure there's no cracks, breaks to the actual housing, and then you'll kind of want to fill up this tube line and just see if you can feel or see anything that looks suspect as far as a hole or crack or whatever, because this needs to be one solid tube from this port all the way down and the sensor. We don't want any leakage in them. And how we check for the leakage is we're going to take just a masking tape, and there's four sensing holes on the flow sensor, and they're kind of positioned at 10 o'clock, 2 o'clock, 4 o'clock, and 6 o'clock on the housing. And we're going to cover those sensing holes . All right, so I got the four sensing holes covered with masking tape. And my visual inspection, I don't see anything that looks suspect. Everything looks good. The housing feels like it's mounted correctly, solid. So what I'm going to do is I'm going to take this piece of tubing and make sure you check whatever tubing you're using during your test that it don't have a hole in it, because that could screw up your test. But I'll connect this to the flow port on top of the blower door, and I'm going to create a vacuum in this hose line. And I'm going to, after I create a vacuum by sucking on it, I'm going to stick my tongue on it, and it should hold for 5 seconds. If it don't hold for 5 seconds, then there is leakage somewhere, either in the flow sensor or in the tubing. So let me run this test real quick. So it held for the 5 seconds. When I pulled it off my tongue, I could hear it and feel like the suction release. So this one does pass the leakage test. If it did not pass the leakage test and I couldn't create a suction that would hold for 5 or more seconds, I want to take a deeper look into this hose running up and also at the sensor housing, make sure that I didn't miss any kind of cracks or something that I could identify. We did reach out to the Energy Conservatory and kind of ask them what they suggest if we did have a leaky flow sensor, and they said that we can change out ourselves in the field some of this tubing, but if it got into where like this housing was cracked or something, you're definitely going to have to reach out to them and probably get some parts or something to fix the problem. So just be aware of that, and make sure after you get done doing this test that you uncover the flow sensing ports. So. All right, so now we're going to conduct the flow sensor position test, and this is easier to do up on a table, kind of like we have here, versus on the ground. We'll just take our blower door, lay it on its side. We're going to take some type of like a straight edge or a ruler, and we're going to lay that across the housing. And basically what we're going to be measuring is this gap in between the bottom edge of our ruler and the flow sensor housing. And we want to be, the specifications on this are you want to be a 1/4 inch plus or minus a 16. So we basically want to be between 3/16 and 5/16 of an inch on here. So I got my ruler set up here, and I'm about 3/16 of an inch on this one. So our housing set in, our flow sensor's set at the right depth. In the guidance that the Field Conservatory gives us, they said if it's out of those ranges, to contact them. I went through the process of contacting them and asked them, what their typical recommendation is on this, and they said typically they just kind of walk you through or help you adjust that fan motor slightly so that the flow sensors are set at the right depth. And what that kind of will look like is if you take this cage off the back side of your blower door or your blower, you can get to the motor mount right here on the inside and loosen that up, and that'll allow you to adjust that fan flow sensor either in or out a little bit for what you need. Awesome. Aside from that, if you notice like there's some extensive damage as far as the motor mount is bent, there's something broken, your fan blades are like rubbing on the housing, something like that, you're going to want to send your blower door in or contact Energy Conservatory, because that's a little more extensive than what you want to get into. But if you just need to slightly move the motor in or out to meet that standard, then you can just by doing that. So. All right, so some kind of general maintenance items in regards to our blower doors. You want to examine the motor cooling holes around like the exterior of the motor and make sure they're not all clogged up with dust. You could either use like a vacuum with a brush or compressed air and kind of blow those out to make sure that motor can cool off. That's not going to get too hot while you're operating it. And this is kind of the back side, and then you got this side over here. You can see it's got holes on both sides of the motor. And then the other thing is you want to you want to check and make sure your blades are about 1/4 of an inch off of the housing, so they're not rubbing onto the housing. Another thing to inspect is just like electrical wires. On this one, you can just see you got your electrical wires kind of running up. You're just checking, making sure nothing's been cut or any kind of issues with wiring. If you're going to be running the blower door for long periods of time, like when you're doing air sealing, you want to make sure there's a flow ring on it, because that helps kind of guide that cool air onto the blower motor and will help keep it cooled down. If the motor gets too hot, it will shut down, and so that could be an indication if your blower motor or if your blower door keeps shutting down on you, you may not be getting enough airflow. So you may want to inspect the motor and see if it's not getting enough airflow on it. The fan should not be left running unattended, and you do want to keep people and pets away as much as possible when you're operating the fan. And then if the fan guards, fan blades, any of that stuff kind of becomes damaged, do not operate the blower door until you can either send it in or call the Energy Conservatory and work through it with them. So those are some of the maintenance routine checks that you should be doing on your blower door. All right, so the Energy Conservatory has a form to kind of track when you're inspecting your equipment. You want to circle, like we just did the blower door. So you want to circle what equipment it is, the serial number, the date you performed the inspection, the technician that inspected it, and if it passed the leakage test, and if it passed the position test.
All right. Any questions on the blower door field calibration?
Dalton, this is going to be stuff that you'll be checking on a regular basis during your production monitoring, correct?
Yes. Yes.
So the forms and tools he's showing you, you guys ought to plagiarize those.
Yeah, you can grab them from the Energy Conservatory.
Yeah, right on their website.
They're pretty simple and straightforward.
Or if you use the tech log to do your field calibration for your gauges, that's good too. So
yeah, so my question has been, how often are you supposed to do this? So how often, Dalton?
Annually, unless you've dropped your equipment or it's got visible damage, then more than annually. So on the Energy Conservatory's website, their guidance is to perform it annually on your blower doors and duct blasters. So.
All right, and then the last video we're going to show, so this is a duct blaster. The duct blaster, again, the fan calibration looks the same as the blower door. But then this last video is kind of the rest of that process. So there's kind of a field calibration procedure where you test the rest of the system. So go ahead and watch this one. We're going to do a field calibration check on your duct blaster system. This test will check the tubing that hooks up to your duct blaster. It'll make sure that the flow meter is reading correctly and that everything's calibrated as it should. The way you want to set this up is on this end we've got our fan set up to depressurize, so the air's sucking out. And you've got your flow meter on this side. We're going to put the ring 3 directly onto the flow meter, making sure we've got the cone part inward towards the flow meter. And then we've also got this flow stabilizer that's going in on this end. So we're just going to put this and you want to kind of push
push back so it's nice and snug in there. Again, put the flow ring 3 on right there. You're putting this all together, and I just use that rubber strip that comes with your duct blaster. And now as far as the other end of it, we've got our standard square piece that comes with your duct blaster. Got it Velcroed in. The other part of this is we have a flow calibration plate from the Energy Conservatory, and this has a known dimension that under 25 pascals they have a specified range of flow that will go through this under 25 pascals. So you got to have this calibration plate for it to work. And in the instructions it says just to tape it on. They don't have any kind of a special ring for it or anything. So let me just making sure I'm kind of lining it up. All right, and then you want to make sure you got this stretched out kind of tight, so there's no kinks or bends. Like I said, this test will help determine if there's any holes in this duct or not. Okay, as far as the hose placement, we've got our flow hose running from the flow port on the fan to channel A or channel B input, and then from the port on the attachment ring, we're going to run that to channel B reference port, and then from our flow meter, our calibration plate, we're going to run to channel A input. All right, so now that we got our duct blaster all set up, the hose is all set up correctly, we want to set up our gauge. We're going to be on pressure flow at 25, so it's reading pressure on channel A, it's reading flow on channel B. We're going to be on duct blaster B and ring 3. And also we want to have our time average at 10 seconds. So you want to make sure you change that. And what we're looking for is we want to be between 103 CFM to 109 CFM. That's the known flow rate through that size of hole at 25 pascals of pressure. So I'm going to go hit cruise on this, and we'll see where we're at. All right, so our pressure reading, we want to be between 24.5 pascals and 25.5 pascals when we take our reading. And right here, we're at 24.9 and 106 CFM. So this passes the test. If we were to go above 109, you want to check your tubing, or even if we're below the 103, you want to check your tubing. You want to check to make sure they're not leaking and the connections are good. You'd want to check this duct to make sure it don't have any holes punched in it, because that could allow more airflow through. So if you're, particularly if your number was above 109, it might mean that you have some holes in your duct. So if you fall outside of those parameters and you check your tubing, your duct pipe is good, everything seems to be okay, and you retest and you are still outside of the parameters, you want to send it into the Energy Conservatory for further diagnosis. All right, so here we got our field calibration check form for the Duct blastr. We've got our company, State of Utah Watt, what gauge I used to do the calibration with, when it was last calibrated, which duct blastr, the serial number on the duct blastr. We've got the date of the field calibration check, who did it, the pressure reading on channel A and the flow reading on channel B, and if you fall within the 103 to 109 CFM.
Any questions on that procedure or anything else we've covered today?
Dalton's going to have his own show rivaling that of Corbett.
He's going to have to get a better cameraman. It was a little down and dirty, but I doubt anybody's going to be watching this, multiple times. We figured it'll do the trick, hopefully help guide you guys a little bit on what the process is supposed to look like. So thank you guys for hanging in there with us. Please use these tools. Please make sure that you're doing this stuff at least annually with all of your equipment. And if we can help in any way, let us know. Let's go ahead and end the meeting. You guys have a great day.
Thanks, everybody.